Hello YouTube, how are you? This is Chris again. We're going to be doing another presentation this time, mostly on computer vision, or more specifically a type of computer vision called a CNN, or a Convolutional Neural Network. It's a mouthful, so I'm probably just going to say CNN or ConNet, just for simplicity's sake. Now there's different types of CNNs, but we're going to cover like the most basic one here. It's going to be pretty long, but we're going to mostly be covering the theory in this presentation. The next one we'll get into the coding if you want to learn to code something and then to apply it to maybe a project that you're working on. Or if not, you just want to learn about the technology that's out there and maybe leverage it for your business, or just interested in how we've learned to adapt computer vision models, or I should say, learn to adapt how humans see things and animals see things, and apply it to computers. I think it's going to be pretty interesting. So, with that, CNN. So, what are they used for? Well, you probably use them already and don't really know it, or maybe you do, but they're used for digital images, classifying and predicting what digital images are. These are pictures or video images. But these are how computers can see and interpret the world. So you can see like this picture here is this could be maybe from a video camera, or maybe from a auto driving car that we have now have cameras around them to help them identify certain things that are around them. This here is identifying a car. You see how it's has a picture frame in the image of the car, and there's on top here there's what it believes to be as car, and then this whole area is highlighted and it has a road. I don't know if you can see that down here. It frames the window, and it puts window up there. So, and there's people walking, and it's identified them as a person. So these are some of the ways that CNNs can be used to classify images and help humans classify images now. And of course, they're used in healthcare for identification of certain ailments and diseases, tumors that are maybe hard to identify, or maybe a healthcare provider is second guessing themselves, so to speak, and they need maybe a second opinion. CNN can be developed to help that physician or the healthcare provider identify certain things in images. So we're going to be getting into a little bit of the history of what they're used for, and a little bit of the history of their origin, and how they're used, how they were discovered, and how they're used today, of course. Now, what do you see in this picture here? If I showed you this picture, I'm showing you this picture, but if I said, what do you see in this picture? What do you see? What do you think you would tell me? Well, most people see. This is an old picture. I remember seeing this when I was in grade school. But most people would say, or some people would say at least, that they see an old lady, and then other people would say they'd see a young lady looking away from the picture. But if you look at, if you could picture this as just a nose, and then maybe this is a mouth and a chin right here and an eye, and then here right here, this could be the old lady side of it. And then if you look at this being the jaw line, and then chin, and then a cheekbone right here, you can see like an eyelash, a little bit of a nose, and an ear. And then here, right here, this could be like a lady looking away from you. And the whole point of this is that your brain is hardwired to kind of pick out images, or pick out features, and then with that classify those features as a certain image that you may have seen before. And of course, a little bit of environmental conditioning, and what you've seen in the past helps you to interpret the future and so forth. So if you've never seen something before, it's kind of hard for you to identify it. But that's essentially how we learn to associate things. So, here's another picture here. What do you see here? This is an old picture. Some people say they see a rabbit, and if you can see the rabbit here, this is his little nose. This is his mouth. This is eye, of course, and then here's the ear. And other people would say they see a duck. Is that right? So there's a maybe this is his beak. This is his eye, of course. This is the front of his head and the back of his head. But a lot of times you could see if you look real quick what comes in your head. The first second you would classify it as the right image. But if you look for a couple more minutes, you might say, "Oh, actually, I see a rabbit there, or it could be a duck or something." So, but the point is that your brain looks at and picks out certain features and learns to classify images based on them. So it's interesting. One of the first studies that was ever done with how our brain works, how humans' brain works, were actually done on cats. Really interesting study done by Hubel and Wiesel. From the 1950s all the way to the 1960s, they discovered that the occipital region of the brain, which is where our brain, the mammalian brain, processes images, was divided and built upon a hierarchical structure from V1, V2, V3, V4, V5, and all these cells are what they call neurons, which is the primary cell of the brain. Were responsible for processing these certain elements, but depending on where the the information was in this hierarchical structure, depending on what types of images it would process. So certain images, what they discovered, Hubel and Wiesel, when they did study on cats, they would put up instruments or some sort of electrode onto the brain, certain area of the brain of the cat, and what they would find is that they would able to shoot some light or an image bounced off of light into the cat's retina, and it would be processed, and depending on the light, how dark it was, how light it was, and the image, whether it was a straight line, whether it was a horizontal line, whether it was a diagonal line, whether it was several lines, they could see that the instrument would give off a certain, like an alarm sound, and then they could see that their brain was divided up into what they call simple cells, which would maybe be like just straight edges of certain things, and if they held the image on its side, these complex cells would fire off, and this could be a indication that the image was that these complex cells processed images that were diagonal in nature, okay, or upside down, and then hypercomplex cells would be like a combination of those two. So, but this is a pretty interesting study if you want to read more into it. But this is how we first discovered how the brain was able to interpret certain things based on how it was positioned, how much light was being bounced off the image, and so forth. But it's a pretty interesting study, and this is how one of the ways where we tried to apply this to computer vision, as you'll see later. So the first neurocognitron, it's kind of a mouthful, was first invented in 1980 by Fukushima. And this was one of the first programs I was actually able to take advantage of those simple and complex neuron cells that we spoke about last, and how they were devised into a hierarchical structure and was able to update using certain parameters, and was then able to be classified as something. But this was the very first attempt here at a network architecture, what they call multi-layered artificial neuron. So Jan LeCun, in the 1980s and 1998, Jan LeCun was one of the first inventors of deep neural networking, and of course ConNets as well. Introduced a certain ConNet for digital recognition, or even alphabets here, as you can see this picture here. And this was a famous study and paper, the Linnet, which was, I believe, one of the first ConNets used, that is still currently used in like ATMs, how they first identify numbers and certain digits and numbers that they can identify. But this used a training program called backpropagation, which is gradient based. We're going to talk a little bit about that later. But this is some of the things that we're getting currently that's being used today. This came out in 1998, isn't able to scale as well as they can now, but this is, like I said, one of the beginning architectures that's more of the conventional ones that's used today. So, but we're going to be talking about more about how these things work right now. And so, cut forward to now, Alex Krichevsky's, again, I'm probably mispronouncing that name. He gave rise to the